Greetings, Skywatchers, and welcome to the sky above us. I'm James Albury, and I'm your tour guide to the night sky. If you're a morning person like I am, you've probably noticed there's a lot more sunlight at 6 in the morning than there was a few months ago. This means we have to wake up earlier to see the planets and anything else cool that's happening in the pre-dawn sky. Well, there's a reason for that. What am I talking about? Let me show you. From our earliest experiences of watching the sunrise, we've known that the sun rises in the east and sets in the west. But did you know that if you pay close attention to where the sun appears on the horizon, you'll notice that it rises further north and south throughout the year? The ancient Maya noticed this, and they placed markers on the ground to keep track of the location on the horizon where the sun appeared to rise and set each day. This eventually allowed them to build permanent structures that they could use as calendars. For example, they observed that at the beginning of spring, the sun rose due east and set due west. However, by the time summer began, the sun was rising in the northeast and setting in the northwest. Then, 3 months later, the sun rose due east again and set due west. This was the beginning of autumn. Finally, 3 months after that, they saw the sun rising in the southeast and setting in the southwest. This marked the beginning of winter. Those moments when the sun appeared to stop its northward or southward movement became known as the solstices. Solstice, roughly translated, means sunstop. There's one solstice that occurs on the first day of summer, and one that occurs on the first day of winter. We can make these same observations ourselves. Pick a landmark in your neighborhood, a favorite tree, your neighbor's house, or any other prominent structure. And notice where the sun appears to rise or set each day. Record your observations and you'll be amazed at what you'll see. By keeping track of the sun's rising position each day, the Maya noticed that the pattern repeated itself. It took 365 days for this cycle to repeat, giving them a reference point for their yearly calendar. So you're probably asking yourself, what causes the sun to appear to drift north and south in the sky over the course of a year? This is explained by the tilt of the Earth. Earth's rotational axis tilts 23.5 degrees with respect to our path around the sun. This means that the rotational axis of our planet points in a specific direction in space. If you drew an imaginary line from Earth's North Pole straight into space, it would point very close to a star over 400 light-years away. We named this star Polaris because it is near what we astronomers call the North Celestial Pole. If we set the date to June 21st and position ourselves in space so we can see the Earth and the Sun at the same time, and make the Earth large enough so you can see it, you'll notice that the northern hemisphere is leaning more towards the Sun. From our perspective on the ground, the sun appears high in the sky at local noon. As we orbit the sun, you'll notice that although our position is changing, we're always leaning in the same direction. On September 22nd, neither the northern hemisphere nor the southern hemisphere is leaning toward the sun. This marks the beginning of autumn in the northern hemisphere and spring in the southern hemisphere. When we advance time another 3 months to December 21st, we're now on the opposite side of the sun, and again, we're still leaning in the same direction. Notice that the northern hemisphere is now leaning away from the sun, and the southern hemisphere is angled towards the sun. The seasons have reversed. Now, if you're wondering why the temperatures change each season, here's why. On June 21st, the northern hemisphere is angled toward the sun, and as a result, the sun's rays shine more directly on our part of the world. The northern hemisphere is getting a lot of energy per square meter of surface area, and therefore it's warmer. In the southern hemisphere, however, they are angled away from the sun, and those rays of sunlight are hitting them at a shallower angle, thus spreading out the same energy over a much larger area, making it cooler. In March and September, the northern and southern hemispheres are both equally warmed by the sun, therefore we have more moderate temperatures. So, for all you early birds out there, set your alarm and enjoy the sunrise on June 21st. It'll be a wonderful experience. And if you'd like to support our program, click on the Patreon link in the description and you could qualify for autographed The Sky Above Us memorabilia, and you could see your name in the credits of our next episode. The Changing the Seasons is fun when you remember to keep looking up.